The distant blue dot, discovery and setting. In the cold silence of space, 124 light-years away from Earth, a lonely planet orbits a faint red star. It is neither bright nor large, just another dot catalogued by telescopes. Yet on a quiet evening in 2015, that dot blinked back. Dr. Elena Carter had spent 10 years chasing shadows in deep space. As an exoplanetary analyst at the European Space Agency, she was known for seeing patterns others missed. Some called her obsessive. She called it precision. When Kepler 452b was discovered, she had smiled politely. When Proxima b made headlines, she took notes. But when the signals from K2-18b reached her lab, she stopped breathing for a moment. K2-18b wasn't new. Discovered in 2015 by the Kepler Space Telescope, it had already been labeled a super-Earth, orbiting its dim host star within the habitable zone. The news had circulated in academic circles, then vanished into the static of more pressing discoveries. But Elena saw something others didn't. "I'm telling you," she said to her colleague, Dr. Naresh Singh, over half-empty coffee cups and tired eyes. "There's water vapor. There's hydrogen. It's sitting in a temperature band where liquid water could exist. This isn't just data, this is a signature." Naresh blinked, unimpressed. Signatures don't mean signs of life. You know that. But Elena wasn't guessing. For months, she pored over atmospheric readings, decoding the spectrum like a language. K2-18b was larger than Earth, wrapped in a thick hydrogen envelope, with hints of clouds that formed and reformed in unpredictable rhythms. She watched those rhythms like a heartbeat. By 2019, the Hubble Space Telescope confirmed what Elena had suspected. There was water vapor in the planet's atmosphere. The scientific community stirred. Some praised the findings, others dismissed them. But for Elena, it was more than validation, it was a doorway. Her nights grew longer. She spoke less at meetings, more to the screen. She had a name for the planet, Navi, after a dream she once had as a child, of a deep blue world hidden beneath layers of light. But no one else called it that. To the agencies, it was still K2-18b. To the journals, a curiosity. To Elena, it was potential. Then came the anomaly. A tiny dip in infrared light, far too rhythmic to be dismissed as noise. Not large enough to signal a storm, not small enough to ignore. The model didn't explain it. But to her, it was whispering something. "This planet," she murmured into her recorder, "is talking." The lab fell quiet. Data waited to be understood. Scientists prepared reports. But in Elena's world, something had shifted. She didn't need proof yet. She only needed permission to wonder. And far beyond Earth, in the red-tinted glow of an alien sun, K2-18b continued to spin. Silent, distant, alive. The signal was faint, but Elena had heard it. She pressed play again. Voices from the data, the first signs. The lab was quiet except for the soft hum of servers and the distant tapping of Elena's fingers on the desk. Lines of data scrolled endlessly across her screen, but one sequence had anchored her attention for weeks. The signal wasn't strong. It pulsed, repeated, muted yet rhythmic, like something alive, trying to breathe through static. She leaned back, eyes burning, and spoke into her recorder again. Signal anomaly 18-02b. Periodicity is consistent. Temperature variation aligns with mid-latitude cloud movement. Pattern is. She paused. The word she wanted felt too bold. Uncanny. Outside her office, colleagues celebrated a grant approval. Papers shuffled, voices rose. But inside Elena's world, there was only the signal. A strange dip in the planet's spectrum, paired with a subtle chemical signature, dimethyl sulfide, or DMS. On Earth, only life produced it. Usually phytoplankton. Simple organisms. Microbial, but alive. Elena didn't smile. She stared harder. She brought her findings to Dr. Singh again. This time, she came armed with projections, chemical maps, error margins. She laid it all out with precise, quiet urgency. Naresh frowned. DMS is volatile. You know how easily false positives occur. And yet it's there. In the upper atmosphere, she insisted. in concentrations that defy non-biological models. He shook his head slowly, voice soft. If you're wrong, the fallout won't be scientific, it'll be personal. You're putting your name on a ghost. But Elena had already passed the point of hesitation. It wasn't obsession, it was intuition honed by years of silence. She wasn't imagining life, she was following its scent. The Webb telescope's upcoming pass was her shot. The request she filed was buried under a dozen higher priority missions, but she knew how to wait. Each delay was another sleepless night, another whisper from Navi, or K2-18b, as everyone else still called it. Her journal entries grew longer, each one a mixture of calculation and confession. There's rhythm in the vapor. If this isn't life, it's the closest imitation I've ever seen. I think the planet is metabolizing. She stopped sharing those notes. Even Naresh seemed distant now. Not cold, just afraid. Her certainty unnerved him. Then, late one evening, the notification came. Web data set 18-02b. Transmission complete. She opened the file slowly, afraid to blink. And there it was again, regular pulses in the planet's spectral reading, tied to cloud density changes, and accompanied by another spike in DMS. Stronger this time. A chill passed through her. She played the looped graph again and again. The data moved like a breath. Or a heartbeat. No celebration. No shouts. Just a quiet, electric stillness. This isn't noise, she whispered. This is rhythm. The world hadn't seen it yet. The papers weren't written. But in a sterile room filled with machines and algorithms, Elena Carter had found something impossible. And for the first time, she was no longer sure it was trying to hide. The breakthrough, a message in the mist. For 3 days, Elena didn't leave the lab. The web data revealed something far more structured than she had imagined. The atmospheric pulses, initially dismissed as thermal fluctuations, were too precise. Every 16.2 Earth hours, a cluster of hydrogen molecules shifted position, causing a measurable alteration in light absorption. At first glance, it looked like planetary weather. But weather didn't repeat like this. Not perfectly. Not endlessly. She reached out to her contact at the University of Oslo, a computational biologist named Dr. Lien Rowe. Together, they ran simulations comparing the hydrogen flux to known biological rhythms, circadian patterns, metabolic oscillations, even microbial respiration. The results weren't conclusive, but one model fit disturbingly well, a planet-wide biosphere cycle. A biosphere doesn't behave like this, Lien said during their third call. It's too organized. Unless it's coordinated, Elena replied. Unless it's intelligent. The word hung between them, daring either to say more. Neither did. At the agency, tension brewed. Word of Elena's findings had spread beyond her immediate team. Meetings turned political. ESA leadership wanted caution. NASA, which had access to parallel data, urged silence. Speculation was aflame, one spark, and public imagination would erupt. They weren't wrong. A partial dataset leaked online, traced back to a corrupted server in Montreal. Within hours, it was trending. Theorists declared first contact. Skeptics blamed machine error. Anonymous posts claimed the hydrogen pulses contained embedded binary sequences. Elena shut her office door. She didn't care about the noise. The signal was still there, beating like a planetary pulse. She narrowed her focus. With Lien's help, she began mapping the DMS spikes and hydrogen shifts as coordinates, layering them over time. What emerged wasn't random. It was a grid, uneven, drifting, but unmistakably patterned. It looked like structure. The thought terrified her. She recorded a new journal entry, this time with trembling fingers. What if we found not just life, but civilization in its earliest form? A planetary-scale organism? A thinking world? There was no proof. Not yet. But something had changed. K2-18b wasn't just a distant orb anymore. It had dimension, rhythm, intent. Then came the final anomaly. A high-frequency burst, barely detectable, embedded in the light curve. It repeated 3 times. A simple pulse, pause, then 2 more. Binary, a natural echo, or something else. She played it again, slowed it down, amplified the waveform. It sounded deliberate. Elena leaned in, her breath shallow. The hairs on her arms rose. Was it a greeting? A warning? Or just the echo of her own desire to believe? No conclusion came. Just that pulse. That rhythm. That possibility. For the first time, she didn't press record. She simply listened. Echoes of life, truth or illusion. The data sat still now, as if it too were waiting. Elena stared at her monitor, surrounded by the glow of blinking servers and hollow silence. The signal hadn't changed. It continued, steady and unwavering, its binary heartbeat looping every few hours like a chant in a language she was only beginning to learn. The scientific community was divided. Some claimed atmospheric interference, others dismissed the signal as a quirk of data compression. The more conservative voices warned of confirmation bias. "We've seen this before," they said. "Mars, Titan, Europa. Promises, not proof." But Elena knew this was different. Not because she wanted it to be, but because it demanded to be. The ESA convened an emergency panel. Global attention had turned to K2-18b, now no longer a quiet entry in astronomical logs, but a front-page mystery. Politicians made statements. Funding for exoplanet research surged. And buried beneath the noise, one question lingered. What if it's real? In that maelstrom, Elena became a symbol. Some called her reckless. Others hailed her as visionary. She ignored both. She only cared about the data, the silent rhythm threading its way through the void. One morning, she stood by the observatory window, watching the sunrise spill across the lab. She imagined K2-18b's own sun, cooler and red, hanging low in an alien sky. Did something, or someone, stand under it, watching back? She whispered the thought aloud. Do they know we're listening? Then, unexpectedly, the signal changed. A minor shift, half a second faster. Then again, slower. It deviated for the first time in months. Was it random? Or a response? The scientists scrambled. Papers flooded preprint servers. Theories mutated overnight. Some speculated that the change was artificial, a controlled modulation. Others feared something else. Contamination. Human technology echoing back into the instruments. No consensus was reached. In the following weeks, Elena stopped publishing. Not from defeat, but from clarity. She had realized something essential. The answer might not come in months or years. It could take a generation, or more. And yet, that didn't make it any less real. She archived her files. Made backups. Wrote a final note. If this is life, we've made first contact, not with a civilization, but with its breath, its pulse. We may never speak with it. But now, we know how to listen. Outside, another telescope array turned toward the red dwarf system. New missions were approved. A probe was proposed, though it would take decades to arrive. The search would continue, carried by younger hands and fresher eyes. Elena left the building late that evening. As the door closed behind her, she didn't feel finished. Just quiet. Above her, the stars shimmered, mute, eternal, watching. And somewhere among them, K2-18b turned slowly, its thin cloud stirring in rhythm. Still speaking. Still waiting.